In this video, we are covering the notes for graphing linear inequalities on a coordinate plane. When graphing linear inequalities, we are not just graphing a line, but a boundary line. This is similar to graphing inequalities on a number line with open and closed circles. But now we're graphing two variables, and so it's a linear inequality on a coordinate plane. So we have three steps that we're going to follow when we're graphing two variable inequalities on a coordinate plane. First of all, you're going to plot points using your starting point and y-intercept or intercepts, just like we have before. Step 2, you are then going to draw the correct boundary line, which is either going to be a solid line or dashed. And then, because an inequality is not just the set of ordered pairs on the line, but it's going to be also an area of the coordinate plane. And these steps will make more sense as we go through a couple examples, but make sure you have these steps written down at the top. If you are still writing, you can hit pause. One thing I just noticed here, make sure you emphasize here, we're going to shade the true side of the boundary line for step 3. All right, let's go ahead and jump into example number 1. So on example number 1, we have x is greater than -2. And so when you have one variable, remember you have your mnemonic device, HOI, VUX. That can help you remember, should this line be vertical or horizontal? And because it's an x, I think VUX, and I'm looking for a vertical line at -2. So I'm going to put a dot at -2. I know this needs to be vertical, and because this says x must be greater than -2 and there's not an equal to, we're going to use a dashed line. And I'm going to go ahead and grab my line tool here. And so I'm going to have a dashed line going through -2. And so that's step 2, is to decide should this line be dashed or solid. And now we need to decide to shade. And if we just simply read our instructions here, it says that we want all the values that are greater than -2. And so on the x-axis, the values that are greater than -2 would be this side. And so you don't need to spend a lot of time shading, just simply enough shading to know that we're looking at all of the values on this side of the graph. All right, example number 2. And our inequality says -2x minus 6y is greater than or equal to -6. So again, step 1 says to graph points on the coordinate plane as usual. What I noticed about this inequality is that both variables are on one side together, and so I am going to use the intercept method to quickly graph this line. So I'm going to find both my x and y intercepts. To find the x-intercept, where I'm going to be on the x-axis, I know the value of y is 0. So I'm going to plug in 0 for y, which leaves me with 6 times 0 is 0. So I'm going to be left with -2x is equal to 6. And when you find your intercepts, you do not need to use the inequality. You can simply write an equal sign because you're trying to figure out where you're going to be at on the x-axis. And so you divide both sides by -2, and we know that the value of x is now -3. And to find the y-intercept, we're going to plug in 0 for x, and 2 times 0 is 0, so that chunk now is gone, and we're left with -6y equals 6. And to get y by itself, we divide both sides by -6, and y is now -1. And so with our two intercepts, we're going to plot them on the graph like so. And now for step 2 is, should this be a solid line or a dashed line? And this is greater than or equal to. And so we're going to use a solid line for this graph. Going through both intercepts. So again, that symbol there told me that we were going to use a solid line for step 2, and on step 1 we used the intercept method because both variables were on the same side. And for step 3, we are looking for our shading. So when, if you recall on this example number 1, we wanted to shade the true side. And so to shade the true side for step 3, when you're in intercept method here, you're going to want to, okay, for step 3, you're going to want to test a point. And so you can pick any ordered pair not on the line. So any ordered pair from the top half of the graph or the bottom half of the graph, and we're going to plug it in for x and y. And so the easiest number, or the easiest ordered pair I always test is 0, 0. So as long as your line does not go through 0, 0, you can test that point. 1, 1 would be easy numbers to plug in. And so let's see if you understand again why I like 0, 0. So if I want to test the point 0, 0, I'm going to plug that in for x and y. When we were doing the intercepts, we just plugged in 0, 1 at a time. I'm going to do it at the same time. So negative 2 times 0 minus 6 times 0 is greater than or equal to 6. And all of that there, times 0, and have 0 minus 0, this whole side over here reduces to 0. And you honestly don't even need to show me this work when you're graphing these lines. For the mere fact this is our first example, I'm sharing that with you. So you ask yourself, if I plug in 0, 0, is this true? Is 0 greater than or equal to 6? No, that is false. All right? And so because 0, 0 is false, that means that all of the other points on this side are true. And so that is how we would complete the 3 steps for example number 2. Let's look at example number 3. You'll find that when you have one variable all by itself, this process goes much quicker because we don't have to test a point for step 3. So let's go ahead and get through steps 1 and 2 here. So step 1, I have one variable all the way by itself, so I'm going to use my slope and my starting point and my slope to graph this line. So my starting point is negative 3. I'm going to place a point there, and my slope is negative 3 over 2. So I'm going to go up and to the left, 1, 2, 3, 1, 2, and I can also go down, 1, 2, 3, and over 2. And so that's step 1 to get those points plotted. And step 3, I'm going to add one more point on here. 1, 2, 3, 1, 2. All right. Step 3 is to decide, am I going to have a solid or a dashed line? And this symbol right here tells me that I'm going to use a dashed line because it isn't just less than sign. It's not less than or equal to. So grab my line tool here and draw in a dashed line. See if I can adjust that a little bit to go through those points. It's easier to draw with a ruler on paper than it is on this program. And so step 3 is now to add our shading, and we're going to go ahead and again, let's read this. It says that y, I want all values for y to be less than negative 3 halves x minus 3. So let's look at your y values. okay? I want y's to be less than so that it's true. And if you would agree with me, these values down here, they're going to be less than this line that this inequality that we just graphed. And so we would shade this side of the graph. If you if you feel more comfortable with testing a point, you can do that. You can plug in 0, 0 in this inequality. And so 0 less than 3/2 x times 0 minus 3. This cancels out because it's times 0. So we have 0 is less than negative 3. And that again is false, which again proves that we needed to shade the other side from 0, 0. So let's go ahead and look at example number 4. So in this example, we have y is less than or equal to 3/5 x minus 5. And so again, step 1, we have y by itself. So we're going to graph using the starting point and our slope. I'm going to start down here at negative 5. And my slope is positive 3/5, so I'm going to go up 3, 1, 2, 3, and over 5. And I only have room for 2 points based on where this graph started, so that's fine. And I notice here that this is less than or equal to, so I'm going to use a solid line. And now we need, for step 3, we're going to choose our shading. So again, right here, it says y is less than 3/5 x minus 5. And so the y's that are going to be less than this are going to be below the line down here. And so, for instance, if this inequality would have been flipped the other way, I would have shaded the top half of the graph. So we're going to have a lot of practice shading different inequalities in this unit. You can rewind and rewatch any of these examples if you want to go through them again. Just a reminder, if you would go ahead and hit pause, try example 5 and example 6. When you're done, hit play and see how you did. All right, so to finish out these notes, let's see how you did here graphing this inequality. And this inequality says y is less than negative 4. So again, I noticed here that I have one variable, and it is a y, so I think hoy. And for my mnemonic device, so I know that I'm going to put a dot on the y-axis at negative 4, and it's going to be a horizontal line. And this line needs to be dashed because this is not equal to, but simply just less than. And again, for my shading, this says I want all values, again, less than, so y less than. So we're going to shade on the values that would be less than negative 4, which would be down here. And lastly here, example number 6, we again have an inequality that we would say is in standard form. Both x and y are on the left side of the inequality sign. So we're going to use the intercept method where we're going to plug in 0 for x to find the y-intercept. So plug in 0 for x, I'd be left with negative 8y equals 16. Plug it in 0 for y, I would have 4x equals 16. And to get y by itself, we'll divide by negative 8. And so y would equal negative 2. To get x by itself, we divide by 4, and x would equal 4. So those are my two intercepts. I'm going to put my y-intercept at negative 2. My x-intercept is at 4. And now I have all of this is greater than or equal to 16. So I'm going to use a solid line for step 2. Adjust that a little bit. There we go. And Now for step 3, shading. Again, when you're in standard form here using intercepts, you do need to test a point for step 3. And so again, 0, 0 is the easiest point to test. So I'm going to test the point 0, 0. And plugging that in, it would be 4 times 0 minus 8 times 0 is greater than or equal to 16. And all of that, 0 minus 0, is going to cancel. So I'm asking myself, is 0 greater than or equal to 16? And so 0, 0, that is not true. So again, this side is false. I'm going to shade the other side. So several of our examples here, or both of our examples when we tested 0, 0, it ended up being false. If 0, 0 is true, you will shade that side where 0, 0 is, as we want to shade all of the values that are true. Let me know if you have any questions. Otherwise, you are now ready to independently practice graphing linear inequalities on a coordinate plane.